Hello, I'm Gabriel Leggett. I'm a senior engineer in the Energy Strategy Research and Development Department with a focus of energy storage. I have experience installing, commissioning, and planning utility scale and community scale energy storage systems. I recently gave a presentation on commercial energy storage, and we covered the basics of energy storage, applications, and the costs associated with the battery energy storage system. So let's begin with the basics.
So a battery energy storage system is simply a way of storing energy to be used later, right? So primarily, the chemistry that is more prevalent is going to be lithium ion, but that's not the only chemistry that's out there. But why is it right now lithium ion? Well, it's because it has a small footprint. You can have multiple cycles, and it is very energy dense. So that's really the one that people are going to pick. So when I continue to talk more about battery energy storage systems, I'm really talking about lithium ion technology. Now, if you go to like a utility scale system, you'll see other things like lead acid batteries, flow batteries. It's just when you get to a large system, it starts to make sense. And if you have the footprint, you can put in other chemistry. And it's really kind of a financial decision as well as the application. So there's different types of battery energy storage systems. So there's kind of behind the meter, front of the meter, utility scale systems. So we're going to be talking about behind the meter systems for commercial application. So over here I have some pictures. Another application would be, we're seeing Tesla's doing this, is the DC fast charger. So if you guys have like an electric vehicle, and you guys roll up and you want to charge your car within, I think it's about 20 minutes you can charge your car. That's a huge demand on our electric grid. So what they'll do is they'll couple that with an energy storage system, a battery energy storage system, and they'll discharge the battery right when you start to plug in, and so that offsets that impact to the grid. So there's a couple applications that you have. Commercial, it's primarily going to be a financial decision, right? You're going to be trying to do demand charge management. So with a battery energy storage system, I want to point out that there's kind of two key factors, and this is really understanding power versus energy. So you'll see it has a rating, right? It says, oh, it's a 30 kilowatt system, 60 kilowatt hours. What's the difference between a kilowatt and the difference between a kilowatt hour? Really, you have power and you have energy. So if it's a 30 kilowatt system and it's discharging at 30 kilowatts, it's going to last for 2 hours because it's 60 kilowatt hours. Now, it is variable. So you can discharge at 10 kilowatts, discharge at 15 kilowatts, but say you're discharging at 15 kilowatts. Well, if it's a 60 kilowatt hour system, you get 4 hours operating at that level. So some of the utility scale systems will be usually 4, 8, even 12-hour systems. But if you're installing a commercial or even a residential system, they're usually 2-hour systems. That's kind of the standard we see. Usually you'll see, I believe the Powerwall is about a 5 kilowatt with, it can max out at 7 for I think about 30 seconds. And its energy is 13 kilowatt hours, I think. 13.5, thank you. So usually around that range, 2-hour system. So some battery terminology you'll see. So when you get your specs sheet for your battery system, you'll see something that says like, okay, well here's the cycles, SOC, which is state of charge. What's the inverter system? What do I need to know about round trip efficiency? What am I worried about ambient temperature? So state of charge is basically meaning how much energy you have in the battery. So if it's a 50% SOC, that means that 60 kilowatt hour system has 30 kilowatts of energy. Round trip efficiency, which is key if you're really trying to make sure that you're saving the most amount of money, means you're not going to get all the energy back that you put into the system. So it's usually around 80%, some as high as 90% round trip efficiency. Basically, if you charge 10 kilowatt hours in, you're only going to get 9 kilowatt hours back. So the inverter, which is a component of the battery, so you have your battery system that stores the energy, and the inverter that converts the DC power to an AC power, is also going to be bidirectional so that you can convert AC to DC. So, in our homes and connected to the grid, everything is operating AC, but a battery system is DC, so we have to have a way of converting it to AC and then converting it back to DC. So cycle just means when you do a full discharge and a full charge. So if you look at that spec sheet and it says we have about 3,000 cycles, 5,000 cycles, you can get an idea of how long the battery is going to last. If you cycle it every day, 365 days a year and you have 3,000 cycles, you probably only get 7, 8 years out of that battery. Some are about 5,000 that we see. You're probably going to get a little bit longer than that. So when you do a full cycle and a full charge, just kind of like with your phone, you notice that if you're constantly draining your battery and charging all the way up, draining it, charging all the way up, your battery life doesn't last very long. So if you really want to optimize your battery system, it's generally preferred to do an 80% to 20%. So you're really only doing a 60%. And that's going to get more life out of your battery system. So the question is there an industry standard of how many cycles you'll have before you need to replace the battery, how long it will last? So a general rule of thumb is a lithium-ion battery energy storage system will last 10 years. And they will usually give you a warranty for about 10 years, right? And that assumes that you're doing daily cycling. Another issue is that the inverter will last about 15 years. So even if you're very conservative with your battery and you're trying to get that longevity, eventually you're going to have to replace the inverter as well. But a good rule of thumb would be 10 years. As for cycles, it really actually kind of depends on what chemistry you have. It also kind of depends just year by year, they get a little bit better. So I used to see some as low as 1,000 cycles. Then it was kind of getting standard 3,000. Now, with the new technology that's coming out, it's about 5,000 cycles you'll see. I've heard some people claim 7,000, but I honestly haven't tested that. It would take me a long time to do it. But it's around that. I would think about 5,000 cycles for a behind-the-meter energy storage system. So the question is, when do you count the battery dead? So what a manufacturer is going to do is they're going to say what's 100% and what's 0%. So even a 0% SOC doesn't mean the battery's dead or it's degraded. You still have a little bit of voltage left. So that's what they consider to be the safe range before you start to degrade the battery. So if you were to discharge all the way to 0 and just leave it and don't charge it up for, say, a month or so, that's going to start to degrade more and more, and you're going to have damage to battery. You're going to get less cycles. 100% is really saying before it reaches any kind of thermal limit, before it becomes unsafe. You can get thermal runaway. So it's really them just saying, okay, here's my voltage curve that I have. Here's the point where I go before I start degrading the battery. Here's how much I can charge it before there's any chance of thermal runaway.
For more information on SMUD's battery energy storage programs, visit smud.org/storagebusiness.